All right, so yesterday we went over the definition of a parabola, and here it is again. A parabola is a set of all points equidistant. That word means same distance, right? From a given point. What's that given point called? That's the focus. And a given line, which we call the directrix. Okay? Now, if I asked you for the definition of a circle, what would that be? It would almost read the same as this. It would say a circle is the set of all points equidistant from a given point, and stop there. And wouldn't have that second part and a given line. Right? A circle is the set of all points from a given equidistant from a given point, which we call the center of that circle, and that equidistant part is that radius of that circle. Now we throw in a second thing. We have a point and a line, and that together it's got to be equidistant to both, and that creates your parabola. Okay. So yesterday we worked with things, parabolas in this form, y equals a times x squared. And we saw that if a is positive, then we get this parabola that opens up, and the focus is going to be on the inside. I'll put F there. Here's our vertex. I'll put a V there, and our directrix is underneath that parabola. I'll put a D for directrix. And then we also saw that if A is negative, that the parabola will open down, but the focus will still be inside the parabola. Here's our vertex, and the directrix will be on the opposite side. Okay. So what's going to happen today is we're going to switch our x and our y. We're going to work with parabolas in this form. X equals a times y squared. Okay. So the difference is we're going to kind of switch the direction. If it's y equals, it's going to open up along the y-axis, so open up or down. If it's an x equals ay squared, it's going to open along the x-axis, right or left. So if a is positive now, along the x-axis, which way is the positive direction, right or left? Right, so what's going to happen now is we're going to see a parabola opening to the right. The focus will still be inside the parabola. Here's our vertex, and the directrix will be this way. So now our directrix is going to become a vertical line, not a horizontal line, and our focus will be to the right of the vertex. And then the other case is if a is negative, then we'll open in the negative x direction, which would be left. So the focus is still on the inside, this time to the left of the vertex, and the directrix will again be a vertical line on the right side of the vertex. Okay. Everything else is going to be the same except for this fact. Okay. So we're going to skip down a little bit. And we're going to use this last page here. And again, we'll start at the last problem. Okay. So it says, number 3 says, for a parabola with a focus at 4, 0 and a directrix at x equals -4, use the formal definition of a parabola to derive the equation in descriptive form. So remember, our focus is a point, directrix is a line, and in fact, when it's an x equals, what kind of line is that? This is a vertical line. Okay. If it's y equals something, it's a horizontal line. If you get that x equals it, you're going to get that vertical line. Okay, so let's sketch what we have here. So focus at right 1, 2, 3, 4. Here's our focus. And we'll call that point F at 4, 0. And our directrix, x equals -4. If you go left 4 on the x-axis, it's a vertical line here. And our vertex for our parabola will be right in between them. And so far, if you haven't noticed, all the parabolas have a vertex so far at 0, 0. Next lesson, we'll start changing that. Okay, but for right now, we're going to not change that on you, okay? And so which way do you think this is going to open? We know the focus is going to be inside that parabola, so we have to open, we always open towards the focus. So if the focus is to the right, we're going to open to the right. Okay. If I go straight above the focus and find this point straight above the focus, can anybody tell me what that distance is going to be? It's got to be 8. Can you explain why? The directrix? Wait. Okay, so this point right now, we know this distance to the directrix is 8. And so we know it's got to be the distance, because the focus is a distance of 8, right? And so why do these both have to be 8? Yeah, and because that's what the definition of a parabola is, right? And so just don't forget that. So we could find, and this has a name. What's the name of this point? It's a special point. We call it it's a focal chord endpoint. There's another one, right? But it's one of them. Because if we drew a chord across this parabola through the focus, that's our focal chord. And so that's an easy point to find. The other easy point to find is the one below it if you go 8 below. Okay, that's just remember this, okay, kind of thing. We don't need that for this problem. I'm just trying to remind you some things from yesterday. So what we do need for this problem are 3 points. We need the focus. We need a generic point on the parabola, which we'll call point P, and just give it coordinates x, y. And then we need a point that lines up with, so it's going to be the same height as our point P on the directrix. And we'll call that point D. And we know something about point D. Oh, I wrote the equation wrong. X equals -4, not 4. So we know the x value is -4. And we don't know the y value. We don't know the height. We do know the x value, okay, because it's on that directrix. And from our formal definition, so these are the 3 points we want. And from our formal definition of a parabola, we know that the distance from point P to point D, that distance right there, is the same distance from point P to point F. So using a little geometry notation, we can write the distance from P to D is equal to the distance from P to F. And then we use our distance formula. So you take your two x values from point P and D, so that'd be x minus a -4, double negative, squared, plus subtract the two y values. In this case, it's y minus y squared. That's the distance from P to D. And then do the same thing from P to F. The x value from P is x, F is 4, so x minus 4 squared. The y value from P is y. The y value of F is 0. And double negatives are positive, so we're going to square both sides, get rid of that square root. And this becomes x plus 4 squared. Y minus y is 0. This is gone. Get x minus 4 squared plus y squared. And then we gotta multiply this out. We gotta figure out what is x plus 4 squared, what is x minus 4 squared. Yesterday I showed you a shortcut. You can use that. On this example, I'm going to do it without the shortcut. You pick which one you want. Because some of us, I don't want that shortcut to confuse us. So if you didn't do the shortcut, you'd do it this way. X plus 4 times x plus 4. That's what x plus 4 squared means. It's x minus 4 times x minus 4 plus y squared. Then you distribute. You get x squared plus 4x plus 4x plus 16. Distribute again. X squared minus 4x minus 4x plus 16 plus y squared. And then combine like terms. So I'm okay if you skip those steps and just go from here to here. Okay, you're okay with that. If not, you can do that work in between. So now at this stage, we notice, okay, we have an x squared that we can subtract out from both sides of the equation. Also, we have a 16 that we can subtract out. And now we're left with 8x is equal to negative 8x plus y squared. I can add 8x to both sides and get 16x is y squared. And there's a 1 in front of that y squared, so now I divide by 16 and I get x is 1 over 16 y squared. So it feels almost exactly like what we did yesterday. The difference is in the picture, it's sideways, right? Okay, so I'm going to give you one more like this, and then we'll do 1 and 2. Okay. Okay, so we'll call it number 4. So you can add it in your notes or on that paper. Okay. Write the equation of the parabola with a focus at negative 10, 0 and directrix x equals 10. Go ahead and do that. Get a nice little picture and equation. Alright, so this is what you want. What x equals negative 1 over 40 y squared. In your picture, the parabola is opening to the left. It always opens towards the focus. The vertex is always in between the focus and the directrix, directly in between. And we get our 3 points. Focus at negative 10, 0. Our point P, it's xy, a generic point on that parabola. And directrix is 10y. We know the x value this time. We don't know the y value. So you got to start with those 3 points. And we know that PD is equal to PF. And use that distance formula. Watch out for double negatives. Y minus y is nothing. It's 0. So we can cross that out. Y minus 0 is just y. Here on this one, I use the shortcut going from my x minus 10 squared to the trinomial. Okay. Any questions on this one? I'll leave it here for a second for you guys to compare yours. Okay, so for graphing, what we learned about graphing yesterday is going to apply to today. Okay, that distance 1 over 4a is going to be important to us. And if you know what a is, just a little side note, if you know what a is and you want to get 1 over 4a, what that's saying to do is multiply a by 4 and flip it over. Right? So if a is a fraction like 1 over 3, if I multiply that by 4, what do I get? If you multiply that by 4, I get 4 over 3. Right? So if I multiply that by 4, I get 4 over 3, and if I flip that over, I get 3 over 4. So if a is 1/3, 1 over 4a would be 3 over 4. If a is 5 over 2, if you multiply that by 4 and flip it over, what do you get? 2 over 20. Which you can reduce, right? But that's all that's saying. You could plug it into the fraction and work it out, but it's saying, hey, multiply it by 4 and flip it over. That's what that 1 over 4a means. So where does that 1 over 4a come into play? Well, say we're working with the sideways parabola, right? And we have our focus here. Here's our vertex. Directrix over here. And so what we're going to see is that the focus is still that same distance. Now it's to the right of 1 over 4a. And also the distance from the directrix to the vertex is that same distance, 1 over 4a. And then if you're going to go, the other 2 points we're going to need to find are the focal chord endpoints, okay, the points that line up with our focus. And the distance between the focus and the focal chord endpoints is going to be double the 1 over 4a. Okay, so if we know 1 over 4a, we can find all these things. And so let's try that on these problems, okay? So number 1. So make sure the equation's in the correct form before you find out what a is. And sometimes it's going to be x equals, sometimes it's going to be y equals, and how do you know which ones it should be? Well, you're going to have something that's squared and something that's not. And so the variable that's not squared is the variable you want to make sure it's solved for. So here x is not squared, so I'm going to solve for x. Y is squared, so I don't want to solve for y. And so I know this isn't the right form. On number 2, y squared, x is not, so I'm going to solve for x and put it in that form. So that's how we know what to solve for. Solve for the variable that's not squared. And so in this case, 1 over 8 is our a. And we want to find 1 over 4a, which means to multiply it by 4 and flip it over. Okay. What do you get when you multiply that by 4 and flip it over? What's that? What's 1/8 times 4? 4 over 8. Flip that over. You get 8 over 4, which is just 2. Negative 2. Okay? So I'll work it out in the fraction form here, but you should be getting negative 2. So 4 times 1 over 8, or negative 1 over 8 is what we do first, which is going to be negative 4 over 8. And then flip that fraction over and you get negative 8 over 4, which is negative 2. Multiply by 4, flip it over. And so our vertex, don't worry about our vertex. Vertex is always going to be at 0, 0 right now. Okay. From our vertex, we need to move a distance of 2. But we need to know, well, is this thing opening up, down, left, or right? Okay. Because it's x equals, it's going to be left or right. Right? So how do we know which way? A is negative, so it's going to open to the left. So I'm going to go 2 to the left. That's where my focus is. Okay, this is my vertex. I'll put V for vertex. And I'm going to go 2 to the right. That's where my directrix is. Okay. So this parabola is opening to the left. Before I graph it, I'm going to put my my focal chord endpoints. So we got 1 over 4a is negative 2. Double that, we get 4. And so a distance of 4 is what I'm going to travel above and below the focus. So I'm going to go up 1, 2, 3, 4 here. I'll put FCE for focal chord endpoint. I'm going to go 4 below the focus. 1, 2, 3, 4. There's my other focal chord endpoint. And so my parabola goes through the vertex and the focal chord endpoints. And there's my graph. And then we go ahead, I'll put D for my directrix here as well. So my focus is going to be at the point negative 2, 0. My directrix is a line, so you better give an equation of a line. What is it? Is it x equals 2 or y equals 2? It's x equals 2. Vertical, this time, careful. Vertical lines are x equals. Focal chord endpoints, we have 2 of them. The one on the bottom, I'll start with, is at negative 2, negative 4. The one on the top is at negative 2, positive 4. Okay. So number 2, what's the first thing we need to do? Solve for x. Solve for the variable that's not squared. So 2x is equal to y squared. There's an invisible 1 in front of that y squared, so we're going to divide it by 2. And we end up with x equals 1/2 y squared. I'll give you a little time to work through the rest of this. We want to find 1 over 4a first, which means you multiply a by 4 and flip it over, right? So if you multiply 1/2 by 4 and flip it over, what do you get? You get 1/2 again. So 1 over 4 times 1/2 is 1 over 2. Okay, so that's the distance we need to move around. Because it starts with x equals, we're going to open along the x-axis, so either to the right or to the left. And because a is positive, we're going to move in the positive x direction. Open in the positive x direction. So our vertex is at 0, 0. Which way is the positive x direction? To the right. And so the focus is going to be to the right of our vertex. So our vertex is here. We're going to go to the right 1/2, so it's going to be pretty close here. What's that? That's only half, yeah. And then I'm going to go back 1/2 as well. That's our directrix. And what do you get when you double 1/2? 1. So from the focus, I'm going to go above the focus 1. That's the focal chord endpoint. And I'm going to go below the focus 1. That's my other focal chord endpoint. So everything is really close together here. And so my parabola goes through the vertex and the focal chord endpoints. So what's the focus? What's the coordinate of that focus, guys? 1/2, 0. What's the equation of the directrix? Directrix is a line, so you better need an equation here. X equals negative 1/2. And then the bottom, the lower focal chord endpoint, let's start with that one. 1/2 negative 1. And then the last one, the one above, is going to be 1/2 positive 1. All right, so you have homework in front of you. We got some time to work on that, so once you're working through that.